All right, now question 2. It's a question on a trigonometry. Yeah. All right, so we have how many questions? Let's see. So, 2.1, 2.2, 2.3, 2.4, 2.5. It's okay. It's a packed question. Look, cinema expressions here where we have to solve without the use of a calculator. Sine equation, sine identity. We are somewhat gonna be using identities even here, right? And then 2.5 is a question on what is this thing called? Triangular formulae, right? Your sine rule, your cosine rule, all that stuff. Okay, so we also did this school level 3, but it was more from a 2-dimensional shapes. But level 4, we are doing 3-dimensional shapes. All right, let me cancel this and then let me hide this for a moment. Just temporarily. Temporarily. Let's answer 2.1. I'm gonna bring up the triangle image once we get to 2.5. So 2.1. Without using a calculator, determine the value of each of the following. So for 2.1.1, the first question, they are giving us one cos 105 degrees. Okay, cos 105 degrees. So since we are solving without using a calculator, we need to be working with what? Special angles, right? 105 happens not to be a special angle. Okay, so we need to break down 105 into the sum or the difference between two special angles, and then we're gonna resolve it into a compound angle. So look, the 105 can be written as 45 degrees plus 60, I think. Yeah, 60 degrees. 60 degrees. Now how did I figure this one out? You know what? Just as an exercise, just take out your calculator. Uzame ukuthi or let me just say, whenever you wanna write down something in terms of a special angle, I'm sure we have 3 special angles, 30 degrees, 45 degrees, 60 degrees as well. So try adding them. 30 add 45. If 105 akaphumi, try the next combination, 13 or 60. If 105 akaphumi, try something else, 45 and 60. This is how I figured out 105. Okay, sometimes kuyafuneka ukuthi subtract instead of adding. Okay, instead of adding. So for this particular question, we're gonna resolve cos. We're gonna resolve cos to what's happening. Perfect. Okay, so resolve our cos to 45 degrees plus 60 degrees. Let me just confirm one more time. Plus 60, 105. Okay. Therefore, this is now a compound angle. 45 plus 60. Cos 45 plus 60. So using a compound angle, the compound angle cos, we can expand this to cos 45 multiplied by sine 60. Cos 60. Cos 60. Then it changes sign, it minus sine 45 multiplied by cos 45 degrees equal to, so cos 45, it's square root 2 over 2, of course using a triangle swak, and then cos 60, that's a half, minus sine 45, that's going to be square root 2 over 2 multiplied, okay, it's cos sine, back I'm for cos again. It was supposed to be sine 60, not 45, sine 60 la, sine 60. Therefore, this, using our triangles, your special triangles, is gonna be square root 3 over 2 equal to square root 2 times 1, square root 2. 2 times 2, 4, minus, when I times when, it's square root 6. 2 times 2, that's 4, equal to square root 2 minus the square root of 6 divided by 4. Divided by 4. So this is our answer for cos 104. Just remember your special triangles. Some special triangles, we have two of them, right? We have this one, yaga 30 and 60. Then here sino square root 3, no sino 2. Yeah. Oh yes, no square root 3, sino 1, sino 2. And then we have the the second triangle is no 1, 1, square root 2. The 45 and 45. Then we apply also katoa whenever you see a 45, a 60, or a 30 degrees. You use these triangles to get your answers without the use of a calculator. Okay? So the moment you solve without the use of a calculator, just think in terms of special angles. Here's a second one. On the second one, we are presented with a problem. 2, 1, 2. We have sine 15 degrees multiplying cos 15 degrees. Okay? 15 degrees. This looks like a double angle. This can be resolved into a double angle because I know 15 plus 15, that's 30 degrees. It resolves to a special angle of 30 degrees, right? So I need to come up with a way to add 15 or 15 or multiply 15 by 2. Hence I'm saying this is a double angle, but it's not complete. It's not complete. It's not complete. Something is missing. Something is missing. The missing part is 2 in front. Okay? If I had a 2 in front, I would solve this into a double angle. But 2 since I get, here's a little trick again. Here's a trick we can do. I can multiply by 1. Is that the right way of putting it? Let me think for a moment. I can put the 2. Let me just say I can put 2 here. Now feeling him for 2. Sine 15 degrees multiplied by cos 15 degrees. But ngoba initially u2 bekangekho, lo 2 komele ngimfake, but komele at the same time ngimcancel. Yeah, no. That sounds confusing. I have multiplying a 2. So basically what I'm doing, I'm multiplying by 1. But instead of multiplying by 1 as in 1, you multiply by the equivalent of 1, which is 2 over 2. Right? Which is 2 over 2. Because a half times 2 inginikeza ubani 1 back. So the coefficient I know what it's 1. But the desired state, it's if 2 in front of the sine and the cos. So in order to put 2 lapha, I would place the 2 but ngibuye multiply ngobani ngo half so that I get 1 back. So that I get 1 back. If bengifuna maybe 3 in front, I was going to multiply by 1 over 3 so that the 3 cancels that 3. But now instead ngifuna ubani 2. That is why I multiply ngobani ngo half and placing 2 so that the 2 and the 2 cancel out again. Bese ngisala no 1, right? But instead of cancelling them ngibuyisele back to 1, I'm leaving it like this because ngifuna kube nobani no 2 in front of the sine cos. Therefore ngiyoba no half, and then when simplifying this, this is actually a double angle. The double angle kabani ka sine. So it's going to be sine 2 multiplied by 15 degrees is equal to a half of sine 30 degrees. All right, so using my special triangle 30 60, then lana square root 3, 1, and then lana 2. Okay, so sine 30, that is opposite over hypotenuse, right? So this is the angle, the opposite side to this angle, it's a half, and then hypotenuse it's 2. So my answer is gonna be sine 30, that's a half times a half, that's 1 over 4. Okay, let's tackle the next question again, man. 2.2. Calculate the values of x given that 2 sine 2x plus 2 sine x is equal to 2 cos x plus 1. Okay, plus 1. So you want to solve for x where x is element of 0 degrees to a 360 degrees. Okay, so we are basically solving for x. This is an equation, right? So you want to resolve the double angle, okay? You want to solve in such a way that usala na something like this: ratio equal to some value. All right, ratio, what is a ratio? It can be u sine, it can be u cos, it can be u tan, any of the three. Right, you need to only have one, just one ratio equal to some value. But in this case I have 1, 2, 3 ratios. So among simplifier, I want to simplify to a point where I end up with one ratio on one side of the equation equal to some value on the other side of the equation. So the best bet is just to change this sine 2x to its identity, which is 2 sine x multiplied by cos x plus 2 sine x equal to 2 cos x plus 1. Okay, plus 1. So this 2 times that 2 gives us a 4 sine x multiplied by cos x plus 2 sine x equal to 2 cos x plus 1. All right, so before bringing this thing over to the left hand side, I think what we can do first is actually to take out 2 sine x as a common factor. So 2 sine x is common in both terms. So for the first term, 2 sine x, and for the second term there's also a 2 sine x, right? So we take it out as a common factor. 2 sine x is common in both terms. So 2 cos x plus 1 equal to 2 cos x plus 1. Okay, don't do this, do not do this. Oh, okay, yafana de. So let me just divide. Plus 1 versus ya cancelana. No, don't do that. Instead, what you should be doing is actually bringing this over to the left hand side and handling it by taking it out as a common factor instead of dividing by the 2 cos x plus 1. So you're gonna do the following: 2 sine x 2 cos x plus 1 minus, in bracket, put this in brackets, plus 1 equal to 0. Okay, again you have now another common factor. Do not divide by it. So let's say we have another case, a different case scenario, maybe say maybe 2 tan x multiplied by cos x, say maybe plus tan x equal to tan x. Then you have the tan is actually a common factor, you take it out. With the tan x, so 2 cos x plus 1 equal to tan x. Bese uthatha lo tan divide ngalo tan. Don't do that. Because you'll end up losing a solution if you end up if you actually do that. So we're gonna erase this part. Instead, we bring it over, then we take it out as a common factor. So the 2 cos x plus 1, this is actually a common factor. So taking this out as a common factor, kusala 2 sine x minus 1 equal to 0. Then we're going to have 2 cos x plus 1 equal to 0, or the 2 sine x minus 1 equal to 0. Then cos x is equal to a minus half, and then the sine x as well is going to be equal to a positive half. Then we find a reference angle. Reference angle for this 0.5 for a half of cos gives me 60 degrees. And then reference angle for this one as well, it's gonna be 30 degrees. It's gonna be 30 degrees. All right, so where is cos negative? It's the second quad and the third quad. So for this solution, we're gonna have our answers were in the second and the third quadrant. So x is equal to, in the second quadrant, we're gonna have 180 minus as the reducing formula. So 180 minus 60, I'm getting 120. In the third quadrant, x is equal to 180 plus the reference angle as the reduction formula, as the reducing formula. So 180 plus the 60, I'm getting 240. Then doing the same thing, Lana, half sine is positive, so the half is positive. So I'm looking for quadrants where sine are positive. That's the first quad. That is the first quad. So x is equal to 30 degrees. And then in the second quad as well, sine is positive. So x is going to be equal to 180 minus 30. So the answer is going to be 150. It's going to be equal to 150 degrees. All right. So I'm going to have my first solution as 120. Next one 240, another one 30, another one 150. So these are my solutions for that equation. And the solutions, if we are bigger, they are actually between 0 degrees and 360. Okay, so these are the solutions for that equation. 2.3, we are presented with a identity problem. Okay, prove that tan x plus cos x over sine x is equal to 2 over sine 2x. So you need to pick a side and then you simplify and show that it's equal to the other side. So for this particular problem, we're going to take the left hand side and simplify it. The left hand side, it's tan x plus cos x divided by sine x equal to, so we change the tan, so the tan is an identity, so we change it to sine x over cos x plus cos x divided by sine x equal to, then what do? We cross multiply sine times sine, that's sine squared x, plus this cos times that cos, it's a cos squared x, divided by sine multiplied by cos, and total cos x multiplied by sine x. I'm doing a butterfly method, where instead of me saying let me find e LCD and multiply everything out by the LCD, I'm taking these two fractions and performing a butterfly method. You take the denominator, you multiply with that numerator. You take this denominator, you multiply with that numerator. Then you come back and multiply my denominators work. Okay? Now, a sine squared and a cos squared, they are also identities. We write it as 1, the numerator. Cos x multiplied by sine x. Okay, sine x. Now just pay close attention to the right hand side. This is the right hand side of the identity. On the numerator we have 2, and on the denominator sine 2x. This simply means that we need to view this as a double angle, but something is missing. Again, just like Lapago 2.1.2, something is also missing in this particular problem. What is that? Ushota ubani? 2. I can put the 2 there, but I need to make sure I am cancel. Right? I need to write the 2 as an equivalent of 1. Alright? Ngifuna ukubhala u3 as an equivalent of 1. It means that I need to take this 3 and multiply 1 over 3. I'm writing 3 as an equivalent of 1. Ngithatha u3 ngiyambhala, but kumele ngimultiply by its multiplicative inverse. I want to write 4 as an equivalent of 1. Ngimultiply ngobani? Ngo3. I mean ngo 4. This is an equivalent of 1. Alright? So mina nangabe ngifuna uthula, I need to write it as an equivalent of 1. So it means that that 1 lapha phezulu I need to change as well to a 2. Ngoba la ngaphansi kuno 1, nangaphezulu kuno 1. Okay, let me just do this. Yeah. Ngiyofaka u2, ngithi divide by 2 cos x multiplied by sine x. 2 over 2, it's 1. I'm writing u2. Why ngifuna u2? It's because of I want to change this to be an identity of sine 2x. So I cannot just write it sine 2x. I need to have a 2 in front. So I'm putting the 2, but at the same time I'm writing it as an equivalent of 1. That's why ngiba no 2 phezulu no 2 ngaphansi, because 2 over 2 it's 1. Okay, that's gonna be 1. Then go about 2. Then this is an identity, which is sine 2x. This is the final answer. Okay? It's the same as the right hand side. Now it's the same as the right hand side. Okay. 2.4. Given that cos 33 degrees is equal to q, express sine 66 degrees in terms of q. In terms of q. Alright, there's many ways to approach this problem. There's many ways. But first, let's do this. I'm given a sine 66 degrees, right? Given that cos 33 degrees is equal to q. I'm given that cos 33 is equal to q. Express sine 66 in terms of q. It means that I need to find a way to rewrite sine 66 in terms of cos 33 so that I can write it in terms of q. So I need to take this sine 66, 33 multiplied by 2 gives me 66. So it means that I'm dealing with a double angle. So the sine 66 can be written as 2 times 33 degrees. So simplifying this gives me a 2 sine 33 multiplied by cos 33 degrees. Alright, I know cos 33 is equal to 1 q, but what about sine 33 degrees? So I need to take this a step further and also rewrite or express sine 33 in terms of cos 33. This is figured out, this is worked out, q low, right? Q, but I need to simplify sine 66 first, sine 33 further. Now, there's an identity, a well-known identity that says 1 is equal to cos squared 33 plus sine squared 33 degrees. All right, it can be any value. It can be x, it can be a, it can be b, as long as the angles are the same and my ratios are also squared, I'm always going to get a 1. Okay, so I'm going to take this and transpose it to the left hand side. You got no 1 minus cos squared 33 is equal to sine squared 33 degrees. All right, but then lana sine 33, not sine squared 33. So I'm going to take the square root on both sides as well, so that I end up with square root of 1 minus cos squared 33 equal to sine 33. So where does sine 33? I'm gonna put this down. Okay, this is gonna be equal to 2 square root of 1 minus cos squared 33 multiplied by cos 33. So this is the end goal. This is the end goal. The end goal was to rewrite this in terms of cos 33 only, so that you replace the cos 33 by q. This is now going to be equal to 2 square root of 1 minus cos 33. We know good it's q, so it's going to be q squared multiplied by q. I'm going to write the 2 and the q next to each other, then like over 1 minus q squared. Now this is how we rewrite sine 66 in terms of q. Okay, so this is 2.4. Now for the last question of 2.5, we are dealing with a triangle. Now before we solve this problem, I have a question. I just want you to think about it before we engage on the following discussion. The question is, how many triangles can you spot in this figure? Just think about it. I see 1, 2, 3, and 4. I can see 4 triangles on this diagram. So there's 4 triangles. All right. So another important thing to note would be, we only apply SOHCAHTOA in a right angle triangle, and then for the rest of the triangles, that is where we apply our rules, your cosine rule, your sine rule. Okay, of course in the right angle triangle you can still apply them, but it's way more easier and way more quicker to use the SOHCAHTOA over a right angle triangle. It's much more quicker that way. Then for the rest of the triangle, we save some rules. Yeah. 2.5, in the diagram below, B, D, and C are the 3 points on the same horizontal plane. Number points now. They are 3 points on the same horizontal plane, and AD is the vertical tower in meters. AD. It's a vertical tower in meters. The angle of elevation from B to D. No. The angle of elevation from B to the top A, it's 25. And then the angle of elevation from point C to the top A of the tower is 50 degrees right here. BDC is 105. BDC now. AB is equal to 15. AB 15. And AC it's 12. Determine the length BC. Determine the length BC. Let me erase now. Determine the length BC. We want to calculate the length kabani ka BC. Alright? Ka BC. So we want to use this triangle, the bottom triangle, this one, the blue triangle, to work out the length ka BC. How do we do that? We need to calculate the length. First of all, we need to find the length BD, this length here. Then we also need the length DC, this length here. So once in tola le length yala, na le length yala, I can use the cosine rule to calculate BC afterwards. Okay, so I'm gonna start off by using this triangle to work out this side, and use this triangle to work out this side, and use the cosine rule for the blue triangle. Okay, so we're gonna start off by saying in triangle ABD, in triangle ABD. So in that triangle ABD, it's actually a right angle triangle. So we're gonna apply uso katoa to work out the base BD, which is the adjacent side to this 25-degree angle. So we're gonna say cos 25 degrees is equal to adjacent over hypotenuse. Adjacent to BD, hypotenuse is 15. Then over 1 ya cross multiplier, ngithola to BD is equal to 15 multiplied by cos 25 degrees is equal to 15 times cos 25. That is 13,59 meters. Okay, meters. Then again in triangle ADC is equal to, for that adjacent side DC, I'm gonna say cos, it's so so I'm trying to explain it as clearly as possible. So cos, it's the right? Cos, it's adjacent over hypotenuse of the angle, the given angle. We are given 50 degrees in triangle ADC. So I'm going to use the 50 degrees to work out the adjacent side. So cos 50 degrees is equal to adjacent to DC over hypotenuse, it's 12. DC is over equal to 12 multiplied by cos 50 degrees is equal to 7.71 meters. Yeah, 71 meters. So now that we have this side as well as this side, we can now apply a cosine rule to work out to BC. Therefore, in the blue triangle, in triangle BCD, in triangle BCD, we're gonna say BC squared is equal to BD squared plus DC squared minus 2 BD DC cos 105 degrees. BC squared is equal to, what is BD? BD we just calculated to BD, that's 13.59 squared plus, what is DC? DC it's 7.71 squared minus 2 BD 13.59 DC 7.71 multiplied by cos 105 degrees. Let's find the answer. 13.59 squared plus 7.71 squared minus 2 13.59 no 7.71 multiplied by cos 105. So tola an answer that is 298,369,7,497. Then we take the square root on both sides. Square root of answer, I'm getting OBC, that is equal to 17.27 meters. So this is how we calculate OBC for this tower. Alright, so this concludes our discussion for question 2. I hope you enjoyed. Check out the description box for more content and you create for this question paper. So for now, I'll catch you on the next recording. Bye bye.